Inspire Extrude is an easy-to-use CAD-based interface. You won't be required to complete steps such as meshing or boundary condition creation manually. All these operations are completely done in the background with no user intervention. One of the main goals of extrusion analysis is to understand how the material deforms through the die openings and forms the extruded profile. The file imported shows a die assembly in transparent gray. Using the Orient tool, we can set the orientation direction for an extruded profile and correctly position the model along the Z-axis. Once the die assembly is oriented along the Z direction, the cavities in die cap, die mandrel, and the feeder can be created and modeled using flow volume toolbar. This region is often denoted as negative volume or flow volume. Click the flow volume icon and select the dies to create the flow volume. Use left mouse button to draw a rectangle around the die geometry and to select all the die solids as shown. Release left mouse button to extract flow volume automatically. User can refine the negative volume created from the die assembly using hide and isolate option to delete or combine solids if needed. To extract bearing region, zoom into the area where bearing starts. Click the bearing icon. Select the bearing start surface. Program will automatically scan the geometry and discard the relief region and create bearing and profile solids. Also note that once the bearing is extracted, you will be prompted to specify lengths for bearing and profile solids. Profile is included in the model to capture how the profile deflects. Use the Organize table to organize the flow volume solids. Volumes can also be organized manually. From the extrusion ribbon, click the Organize tool. On the guide bar, click Plane and select the plane through which to cut the solid. The saw depicts the cutting tool. The plane to select becomes highlighted when the saw is moved. Click Cut or right-click to cut the plane. Right-click on the selected part and select Organize As from the context-sensitive menu to organize the solid. Using the Organize tool, cut the flow volume solid at different Z locations and organize the cut solids. From the extrusion ribbon, click the Billet tool. In the micro dialog, define the billet dimensions. Use the Material tool to select materials for the analysis. Select the appropriate materials for run the analysis and load the results. Click the various result types to detect flow imbalances at the die exit. Understanding the material flow in die regions such as portholes and pockets help in redesigning to improve the performance of the die. Further, user can do a bearing optimization. Bearing length optimization can be performed to ensure the velocity of an extruding profile at the exit is uniform. Inspire Extrude automatically decides the time step data to be used based on ram speed, ram acceleration time, upset billet length, butt length, and will be considered when user submits a transient simulation. However, user can edit the default values and control or change the time steps for a transient problem. When extruding multiple billet cycles, the new billet material welds with the material left in the pockets and feeder plate from previous extrusion. The quality of the material in this zone may not be acceptable and usually sheared off. This sheared off region, known as butt length, can be computed by performing billet interface tracking analysis in Inspire Extrude. During extrusion process, it is important to prevent the impurities in billet from entering the product. Billet skin tracking analysis can be used to determine when the billet skin enters the extrusion product. Tool deflection analysis determines where and how the tool is likely to deform during extrusion process. It also helps the die designer to make the corrections in the tool components accordingly. Inspire Extrude provides 3 different ways to perform tool deflection analysis, either through coupled flow, thermal and stress analysis, or by writing a FEM file that contains tool mesh, material data, and BCs which can be submitted to OptiStruct Solver for stress analysis. In above both cases, model should contain both workpiece and the tool components. Tool deflection analysis can also be done using the analysis wizard in Inspire Extrude. Quenching or cooling after extrusion is very crucial for controlling grain size and mechanical properties of the profile. Inspire Extrude can be used to set up and run a quenching simulation. Import the profile geometry and set the orientations. By clicking on the imported profile solid or surface, the length of the profile solid is set. Using the quenching interface design, immersion cooling, spray cooling, air nozzle cooling, and air fan cooling quench systems can be created. Create any individual quench system or combination of cooling systems. You are required to select a workpiece and a coolant material. If the workpiece material does not have a TTP curve, default data is assumed by the solver. Specify the puller speed, simulation time, and mesh size, and then submit for analysis. When results are available, you'll be able to post-process them in Inspire Extrude